Oh, I was muted. Okay, we should actually be live now. Welcome everyone to ACDE 172. Not a ton on the agenda today, but we'll obviously cover Dencun, so updates around Devnets, around client implementations and any issues that are coming up. And then after that, we have an update on the EOF work. So there's been EOF breakout calls happening for the past several months. So yeah, the folks working on that will let us know what's been happening there. But maybe to kick it off, I don't know if someone from the DevOps team wants to give a DevNet update, and we can start from there.
Sure, I can begin. So Devnet 9 is still running. We have about 93% participation rate right now. We have Guess and Teku submitting bed blocks, so that's about 100 validators off the 1300 that we have around. So that's another 7%. So if you would bring Guess and Teku back online, then we would be very close to the 100% participation rate. We have a few pairs that are not working though. I think Prism and Aragon is one of them. And Ethereum.js is struggling to keep up with the rest of the chain because we've been submitting transactions and blobs pretty much nonstop. And certain blocks have over 200 transactions, and Ethereum.js is just unable to keep up with that. So Devnet 10 is supposed to launch this week, but I don't think we're going to be able to manage that. So we postponed it to next week, and hopefully next week we can launch it. We would want to have the KCG library available in the consensus back repo, so each of the clients can include the proper KCG files in their next release. Another note, MEV Boost is a work in progress. We have a working relay powered by Flashbot team, and they also have a working builder. And we have quite some blocks that were proposed by their builder. So things are looking good, but I haven't been able to replicate their relay infra just yet. But we have the relay running right here. I just linked the link for that. And currently we have 265 validators registered for this relay. All of those are Lodestar. I haven't had time to mess around with the clients just yet.
Nice.
Are all the CLs ready to test the builder flow?
I guess is any CL not ready? Okay, yes for Teku, yeah, yes for Prism.
Yeah, that's a better way to ask it.
It seems like
I think the only open question was if Nimbus merged the required PRs, because earlier I think all the other clients we were able to test them on kurtosis, but we weren't able to do Nimbus yet.
I don't know.
Is anyone from? Okay, we can ping them later on. Yeah.
Yeah, I don't see on the screen, but there's more than one screen.
So there's a good question regarding blobs going through MEV, and we have not been able to confirm any blob transaction using the MEV relay. So is anyone from Flashbot here? Or any
I think they have an offsite this week, but yeah, that's just something we should pay attention to in the next couple weeks.
Yeah, it would be very good if we could have blob transactions going through MEV also, because right now it feels like all the blobs are getting dropped, even when there's some blobs in the pool. So,
like the builder's ignoring them, or there's some error.
Yeah.
Okay.
But this is like not confirmed behavior just yet. It's just a few examples that I've taken a look where.
Yeah, the main issue is that we're spamming so many blobs that we're almost always hitting the limit, and that just increases the base fee. And we're not necessarily sure yet if the missing blobs are due to the base fee being too high, and there's no valid blobs that could be included, or if the builders, in fact, actually not including blobs that would have been otherwise included. But we'll try and get an answer for that over the next day.
Cool.
And I don't know if there's any other builder other than the Flashbox one. It would be very good if we would have at least one more that we could test out.
Yeah, I'm working on one, and they should be ready soon, TM. But yeah, I can circle around with you guys, and we can work on that.
Yeah, sure. As soon as you have any kind of prototype, we are happy to give it a test also. So just let us know. And regarding Devnet 10, so we would like to iron out all these MEV questions before we proceed to Devnet 10, because there's not much point of running with 300,000 validators if we still have open questions regarding MEV building. So we're going to now hold off with that till we have all of this confirmed.
And the other thing is, because DevNet 10 will be bigger, we want to make sure we have enough of the visibility tools to understand how blob propagation looks. Zato's added support for the event monitoring the event stream for blob-related events. And as far as I can tell, Teco's already included that PR, and Prism has the PR as well. If the other clients could include that soon, that would be really helpful, because then we can get a visibility on every client and when they're seeing blobs.
Got it.
Yeah, and one more quick note that we plan to have about 330,000 validators, which is a churn limit of 5, and we're hoping to make some deposits and exit right after Genesis. And then we're going to have Denkun maybe a day or a day and a half later when all the deposits have reached the chain. And then hopefully we're going to see a cutback from 5 to 4, because we're not going to be able to test for the mainnet defaults. Or there's no point of testing for the mainnet defaults. I think it just makes sense to test going from 5 to 4.
Yeah, that would trigger the same code pass, but using the smaller presets, minimal presets. Is that right?
Yes, that's correct.
Yeah. And I guess I assume we'll keep DevNet 9 running as well while we have DevNet 10 if we're still doing testing on it, because I think it's probably valuable to have it at least for a while, in the case that, say, the 300,000 validators causes an issue or whatnot, like to have DevNet 9 still as a fallback. Is that possible?
Yeah, Devnet 9 is pretty low cost, so
Yeah.
we don't mind to have it around, but we don't know how long we plan to have Devnet 10. And the whole idea is that Devnet 9 should be very stable before we proceed to Devnet 10 with no more big questions, which we still have at this point.
Got it. And so in terms of getting ready for DevNet 10, so you said there's the PR that Perry just linked that helps better track the blobs, making sure that the MEV pipeline works well, making sure things are relatively stable on DevNet 9. And you think in the next week or so we can probably deploy DevNet 10, is that right?
Yes.
Oh yeah, and the trusted setup, yeah. Thanks, Barry.
All right. The trusted setup needs to be updated by all the different clients, and I think some of them need like some recompilation or whatnot. So.
Got it. Yeah, I guess, do any clients feel like it's not realistic to get this up in the next week or so? Okay, and then I know we had talked a couple times about DevNet 10 being like the last DevNet if things go well. So assuming DevNet 10 goes well in the next week or so, does it make sense Does it make sense to then start targeting Gordy in the weeks after that? So either I don't know if by next CL call we'll have seen the results, but the very least by the next Alcor devs we should have. At that point, assuming things are working smoothly, are people comfortable moving to say Gordy? I guess any oppositions or pushback?
I think we should definitely wait for the results of Devnet 10.
Okay. Yeah, I think that makes sense. So, yeah, I think if we can have that if we can have launched it by the next CL call next Thursday, that would be amazing. Yeah, and we can discuss it further there. Yeah, I guess any client team want to share more about their progress or any issues they have or anything related to the fork itself? There's a comment by Marius in the chat about Peter wanting to have a discussion about bandwidth. I don't know, is Peter on the call? No, I don't know. Marius, yeah, do you want
to? Yeah, I don't, doesn't seem like he's here. I don't fully remember, but he managed to get his node up and running on Devnet 9 and kind of saw the bandwidth that it was using because of all the blob spam. And it was kind of ridiculous. So he started implementing a transaction handler that will only fetch one blob transaction per run, whatever time that is. So it will not like our current transaction handler would just overload itself because like if you connect to someone that has like a lot of blob transactions, they will announce them all and we will just fetch them indiscriminately. And yeah, I don't know if other clients have thought about this or if other clients also implemented it the way we did. Because like the gas transaction pool actually now tops out at 10 gigabytes for blob transactions. And if you if you connect to a gas node and the gas node announces for 4,000 blob transactions, it will like murder your bandwidth. So yeah, I think we should have a discussion about. I think the consensus layer should have a discussion about 3.6, like the bandwidth for blocks and like blobs and blocks, and we should also have a discussion about the bandwidth for just the transaction spam.
And when you say have a discussion about 3.6, the implication being that like 2.4 would require less bandwidth, or?
Well, definitely 2.4 would require less bandwidth on the consensus layer, but it doesn't have anything to do with the execution layer.
Right.
So the execution layer client teams have to make that decision if they can support it, but they have to keep in mind that there will be blob spam.
Yeah, I know that there was some work done on the gossiping on the CL side. I don't know if anyone who's familiar with that is on the call right now. Yeah, and otherwise, I don't know if any of the other, okay, like clients and the CL networking issues is different. I don't know, yeah, do any of the other ELs have thoughts on this?
I think we are working on similar thing in Nethermind right now, but Marcin, could you share details?
Yes, so we're planning to have some kind of throttling about sending and requesting block transactions, but it's not done yet. But it will be done before the hard stop.
I guess, does it make sense to maybe go into this in more detail on Monday's testing call? I don't know if this gives a couple days for the EL client teams to like look at it a bit more, and then maybe we can have Peter come up there, or otherwise someone else from Get sort of walk through it in more details.
Sure.
Okay, Marius, I will be waiting for you on Monday. And then, yeah, if other client teams want to look at that, by then we can, we can discuss it more then. Any other issues that any client teams want to bring up about the fork? Okay. Anything else that we want to cover before going into EOF? Otherwise, Dano, I think you're the one who's going to share the update. Is that right?
I think so. Don't see any of the other typical people on the call who've been giving feedback on my slides. Do I have screen sharing capabilities?
Try. We'll see. Yes.
All right. Cool. So let me get to. So the big proposal today, well, in the update, is to move Prague towards being headliner to make EOF headliner for the upcoming Prague release. And we're going to give an update of where we're at and what's been developed and what EOF is to make sure everyone's on the same page for what it is. So first, when I say we and our, I think that's important to talk about that. And I can figure out how to work the slides. Okay. And there's 4 major groups of people working on the EVM object format. The first team, the team that created EOF and did a lot of the early legwork in getting it up and running, is Team Epsilon. This is an EF-funded team, and it's focusing on EVM improvements. They also have another project that they run. They make a standalone C++ interpreter, EVM1. And they used to work on the eWASM, so they know a lot about why WASM won't really work from doing it, which is really important to know that through doing it, why it won't work. Second group of people is we have execution clients, representatives from there. We have people from Geth, Besu, Nevermind, and occasionally we've had some Aragons, but they're going to work with mostly Geth's VM, so it's going to be fairly easy to port there. And at least back in January, all the teams had the same quote-unquote big EOF implementation. We were actually doing fuzzing on the container format and on implementations before it was decided that EOF was not ready for Shanghai. Part of the reason we discovered why EOF wasn't ready for Shanghai was this third group that's been involved, very involved in the past few months, the compiler teams. You've had representatives from Solidity and Viper giving very valuable feedback on some details of EOF. A few new features have been added to support them, but mostly it's been working on the finer grained details of, we need this for the compiler. This will solve some size regressions. It's mostly there. We have most of the solutions we have. We know that we need to do in either this release, in a big release, or maybe in a few opcodes in the next release. But their input's been invaluable in validating that what we've worked for EOF is going to work within the compiler teams. And another important thing is that the downstream users of EOF, the compilers themselves, are on board with it. And I think another important group that has shown up is we had some people come in from various data contract teams. Store2 is one of them. They want to use the contracts for data, and they've been interested to see how some of the changes we've been doing from EOF will impact their work. And what we have, there's one opcode they have proposed that would make their job a lot easier. But even if we don't have that opcode, they're confident that what they're doing with that store 2 will work with EOF and will be acceptable for what their needs are. So what is EOF? EVM object format is mostly a container format for EVM code. The big thing is it separates code and data, which is one of the big base problems when it comes to taking EVM and converting it to any other format, is where's the code and where's the data, and can we make hard and fast rules about it? Solidity and Viper have adopted some conventions, but those aren't enforced as part of the container format. Container format makes the separation a mandatory. And it also requires that all code is valid. So if you see bad data in there, you can't see bad code in there that is masquerading as data or data masquerading as code. If it's code, it must be valid and it must be executable. And data can be whatever it needs to be. And the two never mix. And because of this, we're able to fix a lot of EVM evolution problems. A famous one is we're not able to add any opcodes that take immediate arguments because of an interaction that if a jump test is inside of what would become covered by invalid code that would make the next immediate a jump target and get rid of that jump target, in theory, you're changing the execution of the contract. So that is something that was done away with pretty early in the process. And we're also able to prohibit a lot of problematic behavior. A lot of things that get in the way of supporting things like ZK and translation to other formats. And just translation between different versions of the EVM if we need to change things. So that gets us to the next question, how many versions of EOF are there going to be? How is it going to work? The idea is that EOF will operate in parallel with legacy EVM smart contracts. I don't think there's a reasonable way, short term, to ban legacy EVM code. Maybe in long term, once EOF has wide adoption, and we can lock down the addition of new contracts and do that deliberately. But as far as EOF, I think the plan is there will only be one version. And it would be, if we need to update the format, there would be standard translations between the two. But that's not set in stone. But what's planned today is there's just one EOF version and one legacy version. Now, it sounds like we're putting 2 VMs in Ethereum, but we're not. The difference between EOF and legacy EVM are almost entirely in the packaging and the validation of the code, and in some of the opcodes that are supported. But once you get away from that, the EVM, legacy EVM, and EOF are the same. They use opcodes, they use stacks, they access storage in the same way, they access accounts in the same way, they work with message frames the same way, they revert in the same way, memory and transient storage are performed in the same way. It's just a different way to package it. It's whether you're driving a truck or a car, I guess is probably the best way to describe it. There's still 4 wheels, you still have to follow all the traffic rules. There's just a different place to put all of your equipment goes in the back of the truck. So I would say EOF is the truck because we separate the cargo from the people. Now, what are the major features of EOF? Now that we got, an overview of how we're going to do it and where it fits in, what are these big major problems that EOF is fixing? And I've identified about 8 major things that EOF addresses. The first thing is the container itself is a big feature set of EOF to separate data and code. Static jumps, something that people have been asking for years. Now that we can do immediates, is something we can build into EOF. Another thing that people have been asking for years is subroutines. We have a facility that does subroutines really nicely. Code and data separation is another issue that gets up. And finally, some of these things down here are some more recent discoveries as we're working with EVM and working with these ZK systems and everything else. Some things that would be very useful and valuable to make sure that we don't have to mess with EOF, that in theory, this version of EOF could be the one and forever if we get everything done right. The first thing is we're removing code introspection capabilities. That means that you can't take code, put it into memory, and then deploy that. What you execute and what you deploy come in 2 different streams. I'll talk about that in a slide later down. Gas observability is another problem. Let's say we need to change this gas schedule dramatically again. If you can't tell how much gas you're using and you can't control some things about gas, then there's easy solutions to change those schedules. Code and stack validation. is another important thing that we can make sure that we're actually putting in real code, and that makes it easier to add things to EOF without having to reboot the world if we can guarantee that an opcode that is not used doesn't show up until it's used. And the last one that came up in the past couple of weeks that we've been talking about, haven't committed to, is to maybe prepare for address space expansion. A little bit of EVM trivia. Any opcode that takes an address will only take the lower 160 bytes of the stack argument, and the top 100 so bytes or whatever's left over are trimmed. And this is used sometimes, it's useful in some ABI decoding tricks. But if we want to use address space expansion, we need to make space for that. And EOF would be the right time to do it. If we're going to break things that need to be broken for the future, let's break them now in the EOF container. So that's kind of the theme going on there. So the first thing is the EOF object framework described in EIP 3540. It defines a container format, and it's got basically 5 sections: a header, the types for stack validation, the code itself, subcontainers, which is something we'll talk about in code creation. This is basically if you have a factory contract that's deploying other contracts, it's going to show up in these subcontainers. And finally, the data section, where you can store your data and your constant variables. The next EIP, 4200, static relative jumps, fairly simple. We ban 3 instructions, jump, jump I, and PC, and we add 3 instructions, R jump I, and we take the opportunity to add a really useful instruction, a vector jump operation, which will save a lot of code in things like Solidity and Viper compilers. They can do some really useful things with that operation. 4750, we add functions, aka code sections, and this is the subroutine support solution. Code is broken into separate code sections. They're self-contained. To support this, we need to add 3 opcodes: call F, return F, which is basically your go sub and your return sub, and jump F, which is basically tail recursion support. This is something that could be really useful for a lot of recursion solutions. You could jump F into yourself and other things. It's something that compiler people get really excited about. Java wishes they have it, and we don't. So we're going to put it in EOF. And there's also stack height restrictions that are enforced with the opcodes when you go between the functions. So they actually act like functions. You pass in 3 stack items, 1 stack item comes out. You can conceptualize it like that. EIP 663, unlimited dupe and swap, is a really old request to access the full depth of the stack. Right now, it's looking like it's going to be a dupe in, which dupes at an arbitrary depth in an operation called exchange. This used to be swap in, where you'd have 2 immediate arguments. But there's duplication, like a swap 2.3 and a swap 3.2 are doing the same thing. So if we do some neat tricks with requiring them to be in order of the stack, you can access twice the distance with smaller operation codes. We may have a 2-byte variant of the exchange. These are some of the details we're working throughout. Now, the old dupe and swap instructions will remain. Even though we could get rid of them, we don't want to disrupt the instruction set too much. EIP 7480. So now we're getting to some of the higher level requests. And this is for remove code inspection capabilities. And this is the read half of that. So in order to prevent code from being introspected, you should be able to read code that other contracts have. So we're going to have to ban the ability to read your own contract code size and code copy, and also to read other people's contracts codes, ext code size, ext code copy, ext code hash. So the problem is, we discovered in Shanghai, is that Solidity will use this data to write to write constants. They'll rewrite their code sometimes for constants for the constructors. So to accommodate that, we allow access to the data section from within your code. You can load data from your data section, data load in as an immediate argument variant, data size, data copy. And you can access your data in your contract, and you can expose it to other people if you want through methods. It goes in the stack, and the data works just fine. Now, a couple of compatibility things is that the legacy EVM will not be able to use ext code into EOF contracts to ensure this readability results. There are some standard responses that we have planned. It'll look like a really short contract, and you can't read it. And also, data star. I should have dropped that last line. That is something that's under discussion. These may or may not be available to. There's an ext data copy that may or may not be available. So I should have fixed that last night. The right half of the code introspection capabilities comes from the create. And as we know, when we do creates now, we take the entire contract, we put it into memory, we wrap around it to memory, and we deploy those bytes. That is not something that's going to work when the underlying execution is not necessarily interpreted in EVM. If you're taking these contracts and compiling them to a ZK circuit, it makes it really difficult, and you got to have these like terabyte RAM systems to generate the proofs when you do that. So we're going to propose a replacement called Create 3 and Create 4, where you create your contracts, but the code does not exist within the EVM. It comes from outside of the EVM from two different places. Create 3 handles it where the EOF container contains the code you would be deploying. And this is useful in factory situations where you're like deploying another liquidity pool. You know what that pool looks like. So it's going to be in the EOF code, and you're going to deploy it straight from there. So you get your factory together, and it comes all in one contract, and it's all self-contained. So you never have to see the code, and you can deploy it. And the other option is Create 4, and that's where you get it from someplace outside of the EOF container or the EVM completely. And the initial plan is to have it from a new field and a new transaction type. We're going to need to see where SSV winds up in the next few months, or we're going to need to put a new RLP type to get these transactions, to get the contract data in a transaction type. And that's Create 4 is a bit flexible. We could go crazy if we want with layer 2s. We could have layer 2s that have a small stable of contracts that will allow you to do, and Create 4 can access those. But for mainnet, we're just going to do it in transaction type. We need a new return code to handle adding data onto the end of these contracts. And this is something that Solidity have explicitly requested for their immutable values. So they can, if you say that you have a constant finally to initialize in your constructor, we actually write that into the code that's deployed as part of data at the end of the existing data section. So return contract also allows for auxiliary data to be added on to these contracts. Just data, no code. Now, to handle the remove gas observability capabilities, we need to address gas and the call operations. So call code's on this list, but whether or not 7069 advances, call code is not going to be in EOF. It's going to be one of those banned instructions. Call code and self-destruct will not be in EOF regardless of how things shake out in any of these other EIPs. But the remaining 4 operations banned would be gas. You can't query how much gas do I have left. And call, static call, and delegate call. The reason we need to replace call with call 2, static call 2, and delegate call 2 is to remove the ability to specify how much gas. Instead, replace it with passing in all the gas you have with some stipend restrictions and reserval restrictions, so that it's mechanical. And whether the 63/64 remains or gets changed is all transparent to the contract. And what's interesting is we're also going to take the opportunity to remove the output location stack operands to make it even tighter and smaller, because a lot of people just use the return data, and we could do return data copy, add an opcode that can make things smaller and tighter. So your calls can be as low as 4 bytes or 3 bytes, depending upon which variant that you're doing, if you're passing in value or not. Delegate call is not 3 bytes. Delegate call would be like a 3-stack argument, which would really make things a lot more compact on calls. Now, the fallout of this is a really valuable thing. If we need to change the gas schedule and increase S-store operations 5x, there's not going to be any contracts in EOF that are going to be frozen because you can't specify too little gas going on to the next call. This is the problem we had back in Constantinople and something we fixed in Berlin with the access lists. But if you can't specify gas, which is, by the way, that's the default operation of all compilers when you do a call, unless you specify gas, it sends it all. That if we increase the gas, then the solution to a gas schedule change is always send more gas at the top level transaction. And finally, we get to some of the more just details of making sure that EOF works well. 3670 specifies the code validation. We check things like make sure the jump destinations are fine, code sections exist, the containers exist. And it also makes it so we can make future evolution of EOF. If there is code that is not going to show up, we can use an opcode. We can be sure that it's not being used elsewhere. 5450 adds EOF stack validation. This is some inside stuff for compilers to make sure that we can do optimizations and interpreters. This will allow us to create minimal size stacks for contracts rather than creating the big 1024 stack and hoping they don't overflow. We can guarantee through code it's only going to consume 10, and we only need to make a stack of 10. And we can optimize a lot of performance in the interpreters because of this. I'll come back to Marius's discussion at the end of this, but that's a good point. Some miscellaneous notes. There's some corner cases that we need to put in to make sure that things work out well. One notable thing is EOF and Legacy can freely call each other with one exception. EOF cannot delegate call Legacy. And the reason we do that is because the next point, which is self-destruct, is banned. So if you have an EOF contract, you could delegate call to a Legacy contract that all it does is self-destruct, and all of a sudden we have to deal with self-destruct inside of EOF. So that's why we don't delegate call. So you can't use delegate call as an escape hatch to get access to functionality we ban inside of EOF. And another thing is EOF and Legacy cannot cross-create. Your EOF factory can only create EOF contracts. Your Legacy EVM can only create Legacy contracts. This keeps the two worlds a little more rational and a little more sane. So we don't have to deal with this big matrix of what if this happens and what if that happens. It's just a lot easier to implement. So quick summary on the opcodes. There is a net +2 of opcodes available inside of EVM. There may be some more coming. There may be about 4 more coming to accommodate compiler performance regressions, size, and mostly size regressions for code. But the minimum required are these opcodes. To address Ansgar, we're kind of removing self-destruct in Denkun. But in the EOF code, you can't even have the opcode. We can't even have the sweep operation. We're just getting rid of it completely. There's none of this games about can you do it in the same transaction. So we have 9 operations that we are replacing functionality with to deal with the improvements we're trying to do within EOF and the worlds we're trying to change. There are 7 opcodes that we are straight up removing with no replacements. Gas, self-destruct, call code, PC, the EXT ones. And we are adding 9 opcodes to add features that make sense within the EOF. Vector jumps, subroutines, unlimited dupe and swap, and the data support to handle the EXT code. I mean, it's kind of a replacement for the XT, but kind of not really for the code copy and code size, and return contract for creates. So talking about some of the more inside baseball features of what's going on. One of the biggest issues is, of course, testing when you ship things for hard forks. And I think we're going to have a little bit of a different, a little easier time, a little more well-defined time than some of these larger network changes. The reason is the EVM is fairly self-contained. We don't need to worry about network interactions. We don't need to worry about pairing with different CL-EL combinations. I don't think we're going to need the same level of DevNet and testnet. And that's because of the way that we're able to test it. We're going to write explicit reference tests. These are the gold standards for are you a compatible EVM? Is do you run these EVM tests? The client teams can help out because we need to test our own code. And some of our tests become great reference tests when we test the edge cases. The big advantage we have is this differential EVM testing that's been going on. Martin wrote some differential testing. Marius wrote some. Guido wrote some, and they've made some amazing findings. And it's been pretty boring recently with their differential testers. They've been running them for a while and haven't been finding much. Guido's got some, what he's been able to find for Besu so far is a few performance issues, some corner cases that are really creative and inventive that the fuzzer was able to find. Probably get a blog post about some of his findings here in a few months once it's shipped on Hedera's mainnet. But these fuzzers are great at finding these strange problems. And we also have container fuzzing that Martin had written back in December, January to test the container fuzzing. So we can test that. So the big proposal is when EOF is that it would be the headliner for Prague. And I would think it would be 3 to 6 months after Cancun actually ships on mainnet is when we would start or actually ship it on mainnet. My thought of you would ship at least 3 months after Cancun, we would start the testnet cycle. But we'd be doing DevNet cycles well before then. So that over 3 probably. So I think Martin said we can't modify the gas schedule anyway, since most contracts will be legacy. So right, so this gives us the flexibility for EOF to charge different gas schedules. But as far as thinking outside of mainnet, if we had layer 2s that were just EOF, they could have much more flexibility in their gas schedule definitions. If we had ZK systems that were all EOF, they already are doing crazy things with their gas schedules. And self-destruct. EVM is used to have a consensus issue, which some network issues don't happen. Yeah, that's why we need a. That's why we test very thoroughly on the EVMs very extensively. So it's not that it's without risk in testing. The risks are just shaped differently. And Ansgar, in my opinion, I would really like to see one more round of is this as forward compatible as possible regarding gas introspection. But I'm excited to be just brought to mainnet, ideally in the next fork. So yes, so if anyone has any opinions on things that need to be addressed to ensure that EOF is maximally forward compatible, please bring them up. We have calls every Wednesday on weeks off of the execution call at about roughly the same time. Call in with the EVM channel, share all the information that you have, share your opinions. Now is absolutely the right time to bring anything else up. Yeah. And there's still some. The best Discord channel is going to be EVM in the EF R&D Discord. That's the best place to discuss this. So that's the end of my presentation. Open for questions, concerns, comments.
Thank you. Okay, Barton and Bess has a couple questions. Do you want to read them off and yeah, answer them?
Yeah, sure. So my main question is, who is the EOF champion and who is pushing for all of these changes to happen?
I would say Team Epsilon probably has the strongest ownership of it. I happen to have some slides ready because I presented about this at East Chicago. I'd be willing to slide in that role if Epsilon doesn't want to, but I think Epsilon is the strongest, has the strongest stake in this right now.
Okay, my next question would be, do we have a spec list ready? And is the spec list like pretty much good to go? Is it ready?
So we have a HackMD that is a fairly complete list. Basically, it's a complete list. We're not adding new features. We might add some things like jump FI for conditional jumps and conditional calls and an EXT code copy. But the list of possible adds is really slow. And yeah, like client pasted it. And that's the full spec right now. There's some additions that we're talking over with Viper and Solidity that might be added, but that list is also small. There's another list that has the open issues, and those are discussed there. I don't have that on hand currently. But if you go into the EVM channel and scroll back, you'll find the open issues link for sure. But as far as specs, I think the only specs we are missing are the data spec and the create 3, create 4 spec. And I think what's holding off the create 3, create 4 spec is we're trying to get some signal on whether we should propose a field in the SSV or whether we should propose a new transaction type like the blob type. Not where instead of passing in blobs, you pass in contracts. And so there are a couple more EIPs that will be posted. And also just the whole drama with the EIP split. I have been writing EIPs until we get more clarity on that because we weren't sure where those were going to land for the prog release. But it looks like the split's actually going to happen. They're just working on final technical details. Can we begin planning EOF only devnets? So we're about a month away from. Go ahead.
Yeah, you mentioned that we don't need like proper devnets for intra, but I think testing the fork transition is one of the major questions here. No?
Yeah. So yeah, we can test the fork transition for the devnet. I guess my comment about the devnets is we're not really we're not adding new network behavior. We're not shaking out network behavior in the new clients. So doing a shadow fork really wouldn't do much unless we're going to inject new transactions and put in new EOF contracts and execute and exercise the new EOF contracts. Whereas when we were doing the merge and when we were doing withdrawals, shadow forks were invaluable and the best way to test them, I think. So that's, when I say testing is shaped differently, things that were invaluable for the merge, I think more useful is going to be the fuzzing and, probably test networks and I think the best thing we could do is just get everyone to get their contracts when they got versions of Solidity and Viper that will emit EOF, and just compile them down into EOF and see how things work out there. Of course, some features won't work if you're relying on exe code copying. But the stuff that does work, that would be probably the best thing, is to take these existing contracts, just probably go through Etherscan, get all the contracts, and just compile them down, and just turn on the EOF flag. So that would probably be the replacement for shadow forks.
Yeah, my next question would be, is any EA clients have any implementation of this EOF?
Since we're not finalized on the spec, no. We did have stuff on big EOF that was going to be finalized in Shanghai, that was finalized in Shanghai. I think Nethermind, Geth, and Besu had PRs ready that were fuzzing to the same results. So that's that shouldn't take too long. All the heavy lifting's been written into the clients or in the PRs, which is parsing the container and making sure that there's interop between the legacy and the EVM. And a lot of the stuff is already still there. We're using the same opcode loops. We're using the same facilities to access accounts and storage. So it's just wiring those things in there.
Okay. Thanks for all the answers.
There's a question around ERCs. So some ERCs have tests for contract like ERC 721 on received. How would that work without the code introspection?
So if it's what I'm thinking it is, there's supposed to be an interface where you can send, where you call a contract with a certain interface, with a certain function. And if it understands the interface, it says, yes, I support that. Otherwise, it returns, I don't have that interface. So when you check for on received, you're not actually inspecting the bytecode, because in theory, it could be Solidity doing it, could be Viper, it could be faking it out and accepting an on received ABI. So the preambles for these various, even Solidity versions change a bit differently. So you don't actually check the code to see if you're compatible. You call a function that says, hey, do you support this? And if it understands it and comes back and says yes, then you know it's a 721. So EOF supports the current framework transparently. I expect it to.
Thanks. Ben, I don't know if that answered your question fully. If not, feel free to either speak up or post a follow-up.
Yeah, I think it's ERC 165 is the one I was thinking of. So that's got the standard of how you would call a function to say, hey, do you support? And you would be doing that off-chain typically to test for it. Although sometimes you wouldn't when you're being sent stuff, but yeah.
Okay, yeah, and Alex says none of the widely used ERCs actually inspect the code of contracts. Okay, so Lucas has a question. I think, Daniel, you sort of covered this earlier in your slides, but what are the direct benefits of EOF? What does it solve? The complications of the EVM are quite huge. So why is it worth it? Why should we ship it? I know you had a slide with like 8 benefits, so maybe it makes sense to put that back up there.
So these are the 8 things that we're going to support in EOF. And probably the biggest reason we need to change some of these things is the core of the EVM was written over the weekend. These are people that knew what they were doing with computer science. They did compiler stuff, but they only had a weekend to work on it. And some of these design decisions, they didn't have time to think about what were the 10, 20-year implications of it. And one of the things that I think that snuck in is the push with immediates, and that blocks out the ability to add other immediates. And then there's also the segmentation of the code, that you can't have code and data separated. So in order to support all that, we can't change those with legacy EOF, but in EOF object framework, we get a format where that is logical. So what this is providing us is an opportunity to get a path to make this rational, to where when we get broader EOF adoption, we can slowly tamper down the legacy, make it more expensive to submit legacy, maybe just shut off legacy, and get all the features in EOF. And then we could possibly figure out a way to transition legacy to EOF. So that is one long-term possibility. But I think the bigger problem that this solves with EOF is the ability to evolve the VM in a more efficient and modern way, because otherwise we're going to start losing language development to other systems, and that may or may not be a bad thing. But if it's not the main system that mainnet is using, there's a risk that we lose the sum is greater than the sum of the parts. The whole is greater than the sum of the parts. So yeah, there is risk in doing this, and risk that it may not be valuable. But as far as making an EOF, making the whole combination of Ethereum mainnet valuable, this provides a path to solving some of those old problems.
Yeah, so I just don't see how, like, which use cases would this unlock? Basically, everything this kind of unlocks is just making existing patterns in compilers kind of cheaper. But is this really what we're like? What mainnet should evolve to? I think I like this idea of having like EOF only L2s, but then I think in order to support this kind of we need to completely have these two separate EVMs, have the legacy EVM and the EOF EVM, and they cannot interact, and this will break composability, so it's kind of a non-starter. Yeah, I'm just not I've been quite vocal about it, that I don't think EOF is a good idea at all. It's just like, yeah, we're adding some stuff, but we can add most of the things we could add in the existing EVM, and the things that we can't are not quite worth it for me. Like, I haven't really seen a big push from compiler teams really wanting this. Maybe they want this, but and the other thing that I really dislike about it is that now the kind of this verification of the code becomes part of the consensus. When you deploy a contract, the contract code has to be verified, right? And this thing, like, we can shoot ourselves. Like, it's the verifications, as I understand, are not that complex, but we might want to do more complex verifications in the future. And the thing is, like, if I deploy a contract that can evade one of those verifications, then I've kind of totally broken the chain. And so there's a new, it's a new big class of consensus issues that of potential consensus issues that we might get with this, right?
Yeah. Ansgar's got his hand risen on this question, so I'll let him. It seems like he wants to answer some of it. Or do you want to ask a question?
Well, no, yeah, it's only a partial answer, but basically to the question of what is this useful for, and why would we want this? Like, to me, a value of this that I think is maybe a bit less tangible, but also very important, is that right now, a lot of the times when we wanted to make changes, we were always very hesitant because it breaks existing code, or at least potential edge cases. Like, anytime we want to do repricing of opcodes, we have to be very careful. And with address space extension, one of the reasons we didn't end up doing is that it kind of is really hard to make backwards compatible. One of the things that would excite me a lot about EOF is just that, of course, it doesn't fix that we have existing contracts that will still have the same problems. But once we have this out there and maturely supported with all the compilers, we can tell people that best practices to start using EOF, and then at least that means that 2-3 years down the road, we can start to be a bit more easy with making some breaking a small amount of legacy contracts in a somewhat more aggressive way with repricing and all these kind of things, because we have this great new, more robust world that we want everyone to be in anyway. So to me, it just makes it's a really nice transition to, hey, this is the world. If you really want to make sure your contracts are long lasting and have completely reliable behavior, please move over there, over the next 1-2 years or something. So to me, that's very appealing.
Yeah, but this only works if we suppose that EOF is the end all be all of always. And I don't see it this way. There have been changes to EOF even quite recently. And so I think like in 5 years, we will say, okay, EOF version 1 didn't have like these 5 features that we really want, and we're going to do EOF version 2 now. And then we kind of like we're pushing all this work onto client teams. They have to maintain 2 different versions of the EVM, and maybe in the future even a 3rd version. Also like the argument that layer 2 specific EOF versions would be nice because the L1 teams have to maintain are maintaining the EVM. Yeah, sure. Like L2 teams, they don't want to maintain the EVM because it's honestly a pain in the ass. And so now, because they don't want to maintain one EVM, they're going to push all this new EVM work onto the client teams as well, and we have to maintain 2. So I don't see this as just conceptually as a great way. I think L2 teams should maintain their own software and not really depend on L1 teams kind of providing the software for them and them building like small pieces on top. But that's just a personal opinion. So all of everything I'm saying is a personal opinion. But
Right. So there's a lot of issues there, but the one I want to pick out is the idea that in 5 years we're going to keep adding features. We've been adding features to legacy EVM since the beginning. We've been dribbling opcodes. We just added an opcode 2 weeks ago. But there's 2 categories of changes that EVM and EOF would both still support. The first set of changes are compatible changes. You drop in a new opcode. That's easy. And there's incompatible changes like, say, we change what self-destruct does. Those take a lot more changes. So what we're trying to do in EOF, we're trying to make as many of those incompatible changes at one time. So we do it once, so the container format ideally doesn't have to change again and can evolve in compatible ways. So if we need to add a new profile type section, there's an EIP about EVM profiles, we could add a new header type. And that falls into the second point on the left, as we would make invalid byte sequences valid. So if you had that before, you would add it, you could now have it. By requiring validation and requiring things become valid, we make sure that garbage doesn't accumulate on the chain by submitting random bytes to the chain. We're not blocking out stuff that we couldn't do before. There's the only validation that happens in EVM right now is at runtime, and we make sure that your jump destinations are not in the immediate arguments pushes. So we're ready to do some validation, some jump test analysis, but the validations we define are their linear time. We're charging for them now with deploy. And a lot of these decisions that we're making for these compatible changes make it so that all the things that we need to add to EOF don't require us to change the operating structure and don't require us to change new bytecode. So it allows it to live there just the same. One example would be EVM max. If we want to add modular exponentiation, we can add operations that have immediate arguments on it now, which we cannot do in legacy EOF. If we want to add a new argument that has legacy operations, we break stuff. A couple of my slides here show the story of how if we wanted to add our jump with an immediate, we would take stuff that was invalid and all of a sudden move it into immediate data. So we change a jump test and we would move it into immediate data when we would break things if we add an immediate. So stuff like that is what we're trying to fix so that we can grow the EVM in the future. I don't think that, we're not going to be able to ossify the EVM until we ossify the consensus layer. So that, the EVM is going to be frozen forever is only going to work once we freeze forever the consensus layer. Once things stop changing, then things can stop changing. But this structure allows us to grow rationally and to be able to do more things and grow in better ways to deal with these new features. So.
Thanks. Andrew's had his hand up for a while.
Yeah, to my mind, a big benefit of EOF is that it's more constrained. So you have a separation of code and data, and you disallow dynamic jumps. So because it's more constrained, it should improve security of smart contracts and facilitate like verification of smart contracts, either manual or automatic or semi-automatic. So I think it's a step forward.
So I kind of disagree with this idea that we cannot freeze the EVM without freezing the consensus layer. I think those are kind of different things. And at least I like this assumption that once you deploy a contract, it's mostly immutable. But I don't know, like it would not be like we are breaking this assumption with self-destruct, but I see the need for it, and yeah, I don't know. And for the EVMX, I think we can build EVMX without immediates. It would just not be super gas efficient. And I kind of
that's where we're going to start losing compiler people. If we say you can still do it, just not gas efficient, they're going to say, well, I should just build it in Sway or I should use Stylus. So that's the risk that we're looking at.
I see. I understand the risk. I have to think about it.
Yeah,
Guillaume?
it's not a security risk. It's more of an existential. Guillaume?
Yeah, that was actually a question for Marius. I don't see exactly. I don't. Could you detail the argument where it would be harder to maintain, different versions of EOF as opposed to a different fork? To me, it looks exactly the same.
I don't think so. Like if we change the behavior of an opcode in different versions of the EVM, in different versions of the EVM, for example, if we have now one opcode that does gas introspection and one opcode that does not, in our code that's twice the amount of opcodes, and testing kind of explodes because we have to test all possible versions of it. And if we go if, for example, now we have one call, making something up now, but if we have one call opcode that does gas introspection, one call opcode that does not gas introspection, and now we have a new version of the we have a hard fork that changes the order of arguments for the call opcode, then we will have to maintain four versions of the call opcode. That's kind of my.
Wouldn't you just change the format and then maintain one per format version?
Sorry?
Okay, maybe I misunderstood, but I mean, I don't see where the 4 comes from, because for me, if you change the call opcode, you would just, I mean, we can also take this conversation offline. I'm not trying to hog the whole thing the whole time, but I basically I don't understand the four version. I only see 2, because one of them would be associated to one format version, and the new version of the call opcode would be associated to the new format version.
Yeah, but then so then we have a hard fork that changes that changes the ordering of the arguments, for example, and then we would have to either we would have to apply it to both versions, and with this we would have to maintain 4 versions, 2 old ones.
Okay, I get it. Thanks.
I think a more concrete version of that would be address space expansion. If you have a balance operation, one that takes the 20 byte version, one that takes the 32 byte version, that's something that is, if we're going to do address space expansion, is going to be a real issue. And that I think is the best example of how you choose EOF for things you can't do in EVM. Because we can't just, take off the top 12 bytes of all address operations, because there are AVI decodings that depend on the top bytes being ignored. And there are some call data that you can put in that will break if those are not trimmed with some of the pack call data. So there are contracts that would break with address space expansion. And that's why, even though it's a recent thing that's brought up, is what if we want to do address space expansion for rent or whatever other use for it? If we don't bring it in a situation like this now, we can't just break old contracts. And with the container format, we could flag to say, hey, this one trims, this one doesn't. That's probably not the best solution. I think the best solution is just from day one to not trim address arguments in operand stacks and have it be different in EOF and EVM. But these are some of the things going in. Georgius, given all this complexity is 3 to 6 month timeline post-calculation realistic? I believe it is, because we're shutting down the final features, and there's no new features added. We're adding, maybe a few more opcodes to address these features, and we're going to spend a lot of the time testing and implementing. I have been very impressed with the differential fuzzing work that's been going on, and it's found a lot of strange corner cases in very creative ways that I don't think we could write tests to cover. So in addition to writing the deliberate tests, I think the differential fuzzing is going to be a game changer in our testing. I think differential fuzzing and compiling old contracts are going to be, just kind of a different way of doing differential testing, is going to be our equivalent of shadow forks for EOF.
Ansgar, you've had your hand up for a while.
Yeah, I just wanted to say, it sounds like it's probably going to be a multi-call conversation around whether EOF is a good idea or not. I do think basically one aspect of this that was briefly mentioned, but I think will be important, is kind of the relation going forward between layer 1s and layer 2s, and with regards to EVM governance. I think so far, basically, for better or worse, it always felt out that we evolve the EVM and then layer 2s in a way almost blindly follow. I think in the past there have been some ideas around at some point maybe layer 2s just forking off, having their own layer 2 EVM standard. Layer 2s don't seem to love that idea so far, at least. Just one thing I wanted to point out in that context is that Carl, Joaf, and I, we recently decided to initiate some sort of layer 2 EVM governance call for more layer 2 specific topics that's going to kickstart start off next week, and then have an in-person event during DevConnect. I think basically there will be a lot of similar questions coming up from the other side, and EOF might be one example of basically to what extent layer 2s want to just follow the layer 1 EVM. So I just want to already flag, obviously it's too soon now to talk about that, because obviously that hasn't happened yet, but I think this will be a more important conversation around basically how do we govern the EVM? Will we forever have the same EVM between layer 1s and layer 2s? How do we basically merge the interests of these different groups? So I just wanted to raise awareness for that.
Thanks. Yeah, and maybe we can post the link in the chat as well. But it's on the Ethereum/PM repo. So the call is the first call is next Wednesday. I believe, yeah, Guillaume, you were next.
Yeah, I just wanted to give some pushback on the claim that it's going to take that we could have a fork 3 months after Cancun. It's true that the differential fuzzing tools are really useful, but if they had they've been around for a long time, if they had sped up forks, just by the magic of their might, we would know that already. And I think, we're looking at a much longer time, because I mean, this is, Denkun was also supposed to be a fast fork. I don't think, if we look at the two options, Verkle and EOF, both of them we're looking at 1 year of work in any case. And the problem with Verkle is that the clock is ticking, whereas all those advantages that have been touted brought by EOF, they are very nice to have. I mean, I want to make that clear. I am a supporter of EOF. I just don't think it should be coming before Verkle, because Verkle, we have to go through the transition, and the more we wait, the worse it's going to get. And there's really bandwidth, like core development bandwidth for one team. I don't see the urgency for pushing EOF right now, especially if it is that complex. In my opinion, there should be, since this is a format, you can have several format versions. You could deliver all those features little by little. And if EOF was a very simple container, like if that was the only thing the fork was about, I'd have no problem having it delivered before Verkle. But because of that complexity, I think it's very important to focus on Verkle right now and deliver EOF afterwards, or simplify greatly the scope of that first EOF fork, and then I don't have any argument against it.
I guess, yeah, just to chime in on the timelines, like I think historically, like 3 months is like extremely unrealistic. Like what we've done in like a 3-month range is like a difficulty bomb pushback. I think as soon as you start to have actual features, regardless of what they are, like somewhere between 6 and 9 months seems to be our pace. It's also worth noting, like there's a bunch of other stuff people are going to want to do in the next fork. And so, it's probably unrealistic to say we're just going to do EOF and nothing else, and therefore the fork's going to take that amount of time. Same thing with Verkle. And so, I think it's probably a mistake to like analyze it at any level beyond like just relative complexity. Like, is Verkle going to be more work than EOF or not? And then, as you said, is there like more urgency to do Verkle? Because historically as well, like over the past couple of years, it's been kind of interesting where we've tended to do like one big fork and one small fork. So like, we had 1559 and then a couple difficulty bomb forks, and then the merge, and then withdrawals was much smaller. And I would argue Denkun's actually a pretty big fork. I don't think it's like a quick fork. The amount of work on the blobs is quite huge. So like, coming out of this big fork, I think it's worthwhile to consider, like, do we want to move on to something, really big right now? And if there's a time pressure with regards to Verkle because of the state growth, does that like raise the urgency? Or do we want to do something that's potentially smaller and then do Verkle after that? And I think client teams should start thinking about that. I understand that, like, obviously a lot of the bandwidth right now is spent on Cancun, and so it's worth keeping the focus on Cancun and like shipping that before we make a decision about what the next big thing is. At least having it, started to roll out on testnets and whatnot. But I think it seems, at least on the execution layer side, that EOF and Verkle are the two biggest potential candidates so far. So I think if EL teams can start just looking into those more closely and understanding the trade-offs and both in terms of like the value they bring and then the timelines, hopefully in like the next month or two, we can start having like a more focused conversation on like, what do we actually want to prioritize? And by then, we should be rolling out Cancun onto testnets. So the amount of work that's actually focused on Cancun should be going down. And we'll obviously have DevConnect as well, where we can spend plenty of time going over both all the Verkle and EOF updates. EF security, Maris, is that still you?
Yes, that's still me. I think Ansgar said something interesting. he said maybe DevConnect could be a good place to have the do we want to go with EOF at all discussion. And I think just the fact that this is still a discussion means that like we cannot we cannot even talk about timelines. Like there's no consensus that this is happening at all, so we shouldn't talk about timelines. We should talk about whether it makes sense to have this, whether it's a good technical change, and if we all say this is something that we want, if this is the consensus, I'm fine with it. But then we should talk about, is this a priority over Verkle or not? And then we can talk about timelines. But talking about it right now, where we don't even, we have no clear, this is good or this is something that we want, it makes no sense to me. I seem to be in the minority in this calls because I'm the only one arguing against it. But I know that a few people are also not very happy with it. So I would like to. I know the Epsilon team and Dano have spent a lot of time working on this. But I think it's quite harsh to say that after all this time we might not be shipping it. But I think it's even worse to say, let's see, and then in like we push it another 2 years, and then we say, oh, we are not going to ship it after all. And so I think we should make a decision at DevConnect, that whether this is something that we want, and if it's something that we want, then we are going to do it, except for like technical challenges. And if we're saying this is something that we don't think is going to happen, I think it's just fair for the team that has been working on it for all this time to have like a clear decision from everyone. And yeah, I already talked to the Epsilon team about this, and I think it would be really nice to all come together at DevConnect and discuss in person and make a clear decision about it.
Yeah, I think it's like I don't think anyone disagrees that figuring out if we want it is is sort of a first thing before when we'd want it and how long it could take. I also think, yeah, it makes sense to discuss both EOF and Verkle quite extensively at DevConnect. I'm not sure that we necessarily want to take. Yeah, I'm not sure if like a month from now we'll be in a spot where we're ready to like take a final decision. But I don't know. My hope is we can, if teams can get up to speed on both Verkle and DevConnect, both Verkle and EOF in the next month or so, that we can spend the time in DevConnect like going deep into both of those as well as a bunch of other proposals. Yeah, after that we should be in a pretty strong spot to take a decision, both for the next fork where we want to prioritize, but also, yeah, if for whatever reason we don't think EOF is viable, yeah, to make that call at that point as well. Yeah, I feel like we've been going on EOF for quite a while at this point. Obviously, there's the EVM channel we can use to discuss it, but yeah, does anyone have any new topics or questions, things that we sort of haven't covered? Obviously, there's a bunch of objections around, the backwards compatibility and figuring out, how this works with L2s. Is there any other potential concern or question that people feel we haven't touched on so far? Okay, If not, then yeah, so there is the EVM channel in the Discord. We're going to have the L2 call next Wednesday. I forget the exact time, but the agenda is in the PM repo. Anything else anyone wanted to cover before we wrap up?
I have a question on this general set of changes that we're discussing around the overall, what is the right way to think about L1 and L2 divergence? For example, you implement vertical, maybe it's not implemented on L2. Push 0 is not implemented on L2. EOF would plausibly take some time to make its way on L2.
I think that's exactly what we want to discuss on the L2 call next Wednesday.
Got it.
And I think, and part of the reason why it's probably worth discussing there is to have L2 people chime in, right? Like, yeah, because yeah, I agree. Like, I think a lot of people realize that we don't have a super clear vision there. So like, at least getting that conversation started with L2s, yeah, is a good start. Yeah, and then yeah, Ansgar's a comment. Like the first step of this is also bringing the L2s together to chat about this stuff, where there isn't as clear of a forum as for L1 devs, and L2s are obviously way more divergent in how they approach things. So yeah, hopefully we can start.
Yeah, I just want to make sure that people, like, if people want to show up next week, that's of course fine, but they shouldn't expect, like, it might just be a 1 hour call where 55 minutes is about just like, you know, what weekdays do we want to have this call and who should show up and these kind of things. And then maybe we have 5 minutes of briefly touching upon already, like how do we see our relationship with layer 1 or the layer 2 relationship with layer 1 around EVM, but it won't be a big topic yet for next call because it's just too early in the process.
Yeah. And then, yeah, we're also planning, though, a full day at DevConnect as part of the L2 days focused on this topic as well. So I expect in the next few weeks, there'll be more information coming out on that too. Anything else before we wrap up? Cool. Well, oh yes, please.
Can you make sure that we all get invites to those events so that we can participate?
Yes. If so, I mean, all the L1 teams should have events for the L1 workshop, and then if anyone wants to join the L2 L1 day, so that you can apply publicly. I think it's the L2 Beats event. But if you have an issue getting in or getting a ticket and you work on L1, yeah, I guess ping me and I'll try to help get you a ticket.
Thanks.
Yeah. Or just tag L2 Beats on Twitter and ask them for one. Anything else? Okay, well, thanks everyone. Talk to you all Monday on the testing call.
Thanks, Tim.
Yeah.
Thank you.
Thanks.
Thank you.
Thanks, everyone.